with our theme of use it and don't lose it, is this something that also applies to dry ice markets? I know, for example, that just a few years ago, there was a lot of talk around the growing applications for dry ice and meeting that surge in demand. So is recovery and efficiency a theme in dry ice circles?
Well, use it, don't lose it. We could not have said it better ourselves. Calling dry ice production carbon neutral is hardly justifiable unless production efficiency increases significantly, and the best results are achieved by implementing CO2 recovery. The effect would be that significant global demand of dry ice could be met by using half the CO2 that is used today. EIGA, for example, the European Industrial Gases Associations, report on environmental impacts of carbon dioxide in dry ice production. The publication details the impact of CO2 on the environment and dry ice plants and provided guidelines on how to reduce their environmental impact. Smaller dry ice plants are not usually equipped for recovery of CO2 gas. Nevertheless, the gas industry should have a policy to reduce carbon dioxide emissions from the dry ice production units as part of their commitment to climate changes. CO2 recovery has mainly been part of large dry ice production, but the changes mentioned earlier calls for new solutions for dry ice producers. Let me give you some case story of the value of implementing recovery systems. A unit has a daily production of dry ice of 2 tons, which is 4,400 pounds on a 4-hour shift, on a 5-hour shift. The production capacity is 400 kilos an hour. The daily liquid CO2 consumption to cope with this production would be normally 5 tons of liquid CO2 per day. If you're using recovery systems, you could come down to 2.6 tons of liquid CO2 per day. So you actually have a reduction of your liquid CO2 of 48%. The secondary benefits are the estimated tank recharge frequency. For example, based on a recharge of 20 tons liquid CO2 per delivery. Without gas recovery, you need to have a refill of your tank every 4 days. With the gas recovery unit, every 7.5 days. Our range of recovery systems will cover most dry ice production units today. Further to the economy of recovery systems, if you have a pelletizer with a capacity of 120 kilo per hour, you will save CO2 of 1.2 ton per produced dry ice. If you have a pelletizer with a 750 kilo an hour capacity, you will have saved CO2 per ton dry ice of 1.36 ton. One good example is, for example, Pro Trockenice in Germany. Out of 53,000 companies, they received the first prize in the category Nature Friend, Sustainability, Innovation. By implementing CO2 recovery, they have saved several hundred tons of CO2 per year. And this is a fairly small dry ice producer. So the list of benefits of implementing a recovery system is you can reduce your production costs up to 50%. You have a reduction of CO2 waste during the production, which is down to approximately 10% from 55 to 60%. You will gain more dry ice from your CO2 tank. You will have less refill of your CO2 tank, which makes you also less vulnerable during the CO2 shortages. You have less transport of CO2 by truck, hence less carbon emissions. We have an easy installations which does not interfere with existing CO2 pipeline or tank installations. Very small footprint of the unit starting from 2.6 square meters up to 5.7 square meters. So it does not take out very much space as well. Also, low power consumption is making dry ice and recovery system beneficial. It's sustainable and environmentally friendly dry ice production. The arguments that we've heard so far for not implementing recovery systems are: we have access to cheap CO2, it takes up too much space, we'll have high investments and cost and low return on the investment. The running costs are, we have high maintenance cost, and we require high production volumes to be feasible. And it's a very complicated operations and maintenance. Not anymore.